But yeah, as I say, welcome everybody. This is the second run of our RIBA 2030 webinar. I'll go into introduce the kind of the RIBA 2030 climate challenge, as well as the second half of the presentation is really about how you can kind of practically implement that as a practice. And we've started doing some live projects with architects at the moment, and I've fed some of that information into this. So this is kind of ever evolving, but the presentation is essentially in two parts. What is the RIBA 2030 climate challenge about, and what is how do you kind of practically achieve that? So I'll start by saying that we've got a little chat box at the middle of the screen, down the bottom. You can click the icon on the right hand side. You can then type in a question, and we'll try and answer those at the end. A question to the end. Guys, if you can mute all of your mics, that would be good. In fact, I've done that for you on your behalf. Yeah, so we'll leave questions to the end, and we'll get kicked off. And then at the end, we'll talk about some of the other webinars we're doing this month, some really exciting new topics coming up. But for the moment, let's get kicked off. This usually takes kind of 45 minutes, and then we can have questions at the end. So feel free to punch those on the chat box. So by way of a really brief introduction, us fundamentally as a practice, we're independent energy consultants. Our real USP is we've got no bias one way or the other. We've got decades of experience in low energy buildings, both domestic and commercial, and kind of community. And we're here to be very open about sharing information, trying to be as collaborative as possible, and trying to simplify decisions. Make sure you guys as architects can quickly get onto the right strategy for the building. We'll be honest about what's right, what's wrong, and can crunch all manner of numbers to make sure that the decisions that are being made are verified. And that's historically really helped architects, the wider design team, and the clients really have a lot of confidence in what they're doing, and requires them, of course, not to be specialists. That's our job. You guys can continue being architects whilst being supported by a great design team. And finally, just regarding the practice, we can offer support at any stage through a project. So that can be, as even though the pre-planning stage, we can offer strategic advice, and as I'll show you at the end, we can offer support right through to kind of post-occupancy evaluation at the end. So that's a really brief kind of intro, and we'll get into the meaty, more interesting stuff. So the RIBA 2030 Climate Challenge, I'm not going to assume that anybody's read this document. To be honest, it's not that laborious. Surprisingly, pleasantly, it's actually quite a nice document to read. Sometimes these things can be, have reams and reams of paperwork behind them. But actually, this is quite a concise document. I think it's less than 10 pages, which is almost unheard of. And essentially, all of this comes about. RIBA declared a kind of a climate emergency last year, and there is a wider kind of UK and European drive by 2050 to essentially become kind of carbon neutral. And essentially what that means is we're reducing our carbon usage, and if anything, trying to create more energy through renewable technology and stuff than we're actually consuming through transport and the built environment and industry across the board. And that's a really challenging target, and for many decades the UK has been kind of kicking the can down the road, and RIBA have finally kind of put a line in the sand and said, look, to make an impact here, we've got to we've really got to kind of shake up what architects are doing in the built environment. And this document is a great way of doing that. It's been really well received. The one thing that's worth understanding, though, is this document it's not pie in the sky stuff. Everything within this document can be achieved today if you want to, and I want you to remember that. It's not something which relies on evolving technology or stuff that doesn't exist. You can produce a 2030 building or better today if you put the effort in, and it won't cost 3 times as much as a standard building regulations building. So do bear that in mind as you listen to the rest of the webinar here. This is all achievable, you know, and really worth kind of focusing on, because I think you can make quite considerable leaps in your practice just with a bit of extra attention to this. The climate challenge framework is made of 4 constituent parts. So we've got operational energy demand. So these icons on the screen in front of you, we've got top left here is operational energy demand, and we're trying to reduce that by 75% in the next 10 years. Embodied carbon, which is the top right-hand icon, thing like an atom with molecules around it. Whether it's commercial or domestic, we're trying to reduce the embodied carbon in building production by 50 to 70%. Potable water usage, which is the bottom left-hand icon, looks like a water drop, is trying to reduce that by 40%, so the amount of water we use per person per year, or per day, sorry, shall I say, is reduced by 40%. And then there's this kind of new one, which maybe we're not quite so familiar with, and we'll unpack this, which is kind of health and well-being. Now, this doesn't necessarily have a percentage reduction associated with it, but it's more about quantifying health and well-being in a building. And again, we'll go into more detail, but these 4 quadrants make a very kind of sensible effort to kind of more informed design going forward. And as I say, we'll go into these individually. So within the document itself, they've got these lovely, fancy, kind of colourful diagrams here, and we've got 3 out of the 4 kind of quadrants mentioned here. So we've got operational energy, embodied carbon, potable water usage. Don't get lost in the figures here. This is really just showing you the kind of the roadmap. So your pink or red column here is where we are today. We've got orange, which is the kind of the 2020 targets, which is really where you should be, is your kind of potential first step into this. 2025 targets, and in dark green, the kind of the 2030 targets. And this is what, you know, that there's quite a big change here between operational energy and embodied carbon. We're looking at making, you know, 70 or 80% reduction in those targets from where we are today. So what appears to be quite a radical change or reduction in energy usage is actually more achievable than you might imagine. But this is the kind of the roadmap for those people who do want to take it slowly. This is where you really need to be keeping up with by the end of the decade. And they're shown here for the domestic buildings. On the next slide, this is for non-domestic buildings. So they've got a different one for domestic and commercial buildings. So don't get lost in the numbers here, but they're trying to do the same thing. They're just trying to drive down usage quite substantially over the decade. The 4th quadrant here, which is kind of health and well-being, this is what's in the actual RIBA document. And it talks about a few things here, and I just want to go into these in a bit more detail. So a big part of this quadrant is about overheating, is about better understanding overheating and being able to design for that and making sure buildings are more comfortable, more kind of thermally stable through the seasons. We've got daylighting. That's been around for a long, long time. There's nothing particularly amazing here about the daylighting levels, but it is setting a kind of a standard for daylighting, making sure that the spaces are well lit. CO2 levels, again, don't get lost in the numbers here. What this is saying is really we need to do some proper ventilation analysis on a building. And the figure that's quoted there, 900 parts per million, is simply good ventilation. I mean, you know, if you ventilated a building to building standards, hitting that criteria would be absolutely fine. And then there's mention of volatile organic compounds and formaldehyde, and this is coming back to just kind of more responsible man-made materials. Often formaldehydes you'll find in glues and adhesives. VOCs, or volatile organic compounds, those come about through again the use of kind of oils and man-made chemicals, and there are more and more products coming to market which do reduce those, and in an ever more sensitive environment people are getting more reactive to volatile organic compounds. So again, it has touched on these few areas, few key areas of building design and ventilation. But the big one here is overheating, and we'll go into that in a bit more detail later on. So that was a kind of a whistle-stop tour of the actual document. As I say, it's actually quite a short document. So do have a read of it. You can easily do a Google for it, and it will only take you kind of 10-15 minutes to have a decent read through, and it's very refreshing. So probably more importantly, the bulk of the presentation here is about practical steps. It's one thing having a document saying, great, this is what you've got to do over the next decade. But how do we actually realize that? How do we actually realize that? And towards the end as well, we've got some methodologies which Mesh Energy use, and we're starting to use with architects. And you can kind of see how this starts to fit together and how the work is actually done at the back end if you decided to work with us. So operational energy, the kind of the definition, it's worth understanding the definition of some of these things. Again, without getting lost in the detail here, it's worth understanding the definitions such that you can make sense of this and just be better educated. You don't need to understand the detail, but at a high level, it's worth understanding these definitions. So operational energy is really split into two parts. And this is the energy that you might put into heating, cooling, you know, producing hot water, pumps, fans, lighting, that kind of thing. And that's one aspect of energy. So that might make up the bulk of your energy bills. And that would be the same for any building, you know, regardless of its use. And that is called a kind of regulated component of operational energy. But there's also a second part, which is unregulated energy usage. And that is for more user specific or building use specific kind of energy consumption. So you may have a manufacturing facility, which obviously there's lots of machines. They're using electricity, which might not be used for, say, a lab environment or a nursing home environment or a you know, school environment. And so depending on the use of the building, this unregulated section will be very small, or it could be quite considerable. And when you're looking at reducing energy usage, you have to factor in both of those things. And the RIBA 2030 document specifically says that you must include both of those things. And that is what you're focusing to drive down, rather than being kind of specific and just doing a small little part of it. And operational energy use comes back to a number of things. It does come back to fabric efficiency of the building, because that affects how much heating energy is required. It comes back to ventilation, so the air tightness of the building, so that your ventilation system doesn't have to work so hard. But also energy generation as well. You know, there's an opportunity for on-site energy generation to help offset electricity that you would be importing from the grid. And a mixture of all of these things changes as you go through these targets. And as I say, we've started looking at a range of projects, and these numbers aren't too far off the mark. So this isn't just a wild guess here. These numbers actually do manifest themselves and actually be able to hit the targets. The big kind of chunk to start with is the kind of the U values for a building. You guys will be familiar with U values of a building for kind of standard constructions. And on the far left-hand side here, we've got the kind of the current column, which is where you are today with the kind of the notional building regs values. So you've got walls at 0.18, roofs at 0.13, floors, windows, you know, double glazing, nothing particularly fancy there. And the design kind of air tightness value of 5 cubic meters per square meters per hour. That is standard stuff. Gas boiler in there, mechanical ventilation, no solar panels on the roof. That will get you to the current target. As you go through these U values through the decade, if we take it to the extreme and go to the right far end of the decade, in order to meet what are approaching passive house levels of energy usage for a building, the walls have got substantially tighter, roofs probably improved by 30%, floors similarly. Windows, you're into triple glazing rather than double glazing by the end of the decade to do that. And air tightness values of a building have dropped considerably by about 80%. So really, you know, you're into taping joints, off-site manufacture of stuff, and having far better kind of build quality and attention to detail when it comes to finishing buildings off. As I say, these, particularly when it comes to walls with U values like that, they've either got to get thicker, or that you've got to use some pretty amazing materials to achieve that. But as I say, that can be achieved today. There's just some compromises that need to be made. And when we're talking about embodied carbon, actually, I will come back to some of these elements as well, because there's a trade-off with embodied carbon as you drive down the U values for a project. Heating hot water, you're very quickly, even at the 2020 target, really you're verging on air source and ground source heat pumps, and definitely underfloor heating. So low flow temperature emitter systems in the building. Ventilation, very quickly, again, you're into kind of mechanical ventilation and heat recovery. And definitely by 2030, once you get below an air tightness value of 3, which is shown in the 2020 target there, really you've got to seriously consider having a mechanical ventilation and heat recovery system. So beyond 2020 onwards, you need to start thinking about new build schemes anyway that include those. And energy generation, like solar panels, essentially, they creep in as the decade goes on. By 2025, we think that most buildings will probably need about 4 kilowatts of solar on them. And then as you reach the end of the decade, it's kind of, you may need a battery, you may not, to help store excess electricity during the day to offset electricity usage at night. Again, every project will be different, but this gives you a flavour for how it's going. And if you want to meet those 2030 targets today, the kinds of things that you're going to have to be looking at. Embodied carbon is the kind of the second chunk, and when we talk about embodied carbon, there's a difference to be made here, because there's a lot of talk in the press about whole life cycle carbon analysis, which is different from embodied carbon, and it's worth understanding that, because the RIBA 2030 document picks up on embodied carbon only, and fundamentally, what we're saying here is kind of the carbon footprint of a material is what embodied carbon is. So it's what it takes to extract the raw ingredients from the ground, to process that, to get it to site, and to actually, put it together on site. And the best way of thinking about embodied carbon is it's the carbon in the building by the time you kind of get to practical completion. So it's the non-operational stages of the building. It's not the 60, 80 years that the building may be running. It's just up to the point where, the homeowner or the building owner walks in with the keys and starts the first day. Whole life cycle carbon analysis includes, recycling of materials, carbon emissions through heating and stuff during this, 60, 80 year period of a building, or maybe commercially 30 years. So do be wary of that, and don't get too confused. In the RIBA 2030 document, it talks about these kind of areas to improve. So ideally, you're looking at retrofit solutions to buildings rather than knocking a building down and starting from scratch. Obviously, if the material's already there, then you're not having to use carbon to get new materials to site and to extract new materials. You can make use of old things. Obviously, using low carbon, healthy, local materials where possible. Focus on recycling, remanufacturing, reusing materials. And there is the opportunity commercially as well to offset by off-site renewable energy generation and kind of woodland planting. And that is actually mentioned. I don't think that is related to domestic projects. I think it's more aligned to commercial projects where, the density of the buildings in a given space may not allow you to take advantage of some of the areas that you need to for embodied carbon. And this is just an overview of, for different kind of types of buildings. I'll just talk quickly about the residential one here on the right-hand side. These donuts are whole life embodied carbon emissions. And as I say, for the 2030 analysis, it's just the kind of the brighter orange sections here. So you can see for a residential development, half of the building's total carbon life emissions are in the embodied carbon section. So half of the carbon is in that building on day one, and it's that which you're factoring into the calculations going forward for the RIBA 2030 analysis. Warehouses and offices are kind of different proportions. Obviously, in an office, there's only about a third of the carbon compared to its whole life, but residentially, it's considerably more. And this is, if any of you are aware of the kind of the RICS life cycle assessment, this is essentially the different buckets that you put carbon into through the life of a building. So you've got everything from the raw materials on the far left-hand side to the end of life on the far right-hand side, going all the way through to disposal of those materials at the end of the building's life. And again, to graphically show this, embodied carbon as part of the 2030 matrix is these first two buckets. So it doesn't include use and it doesn't include end of life. I said I was going to come back to U value. So before I talk to this slide, one of the paradoxes or one of the struggles which you're going to come across if you embrace this is, as we use more man-made materials to reduce U values of a wall, so use less energy and keep that nice and slender, the embodied carbon in those materials really does rise quite considerably. And so to try and counteract that, if you use more natural materials, your walls get thicker for the same U value. So there is a compromise to be had in building design going forward to reduce the U values and improve the thermal insulation of a building, but use more responsible materials, which might mean that walls get thicker. And obviously that means for a given footprint, there's less internal space in the building. And that's something, again, which will be completely project dependent, but is a trend worth bearing in mind. Embodied energy, kind of hands up here, 3 or 4 months ago, embodied energy was a bit of a mystery to me. And I think this is one of the toughest aspects for this framework for a lot of people to get their heads around, because embodied carbon just seems like so intangible. There seems like so many variables that, how do you get a meaningful number out? If I buy a pallet of bricks from, TP and I buy some windows from Scandinavia, how do you even make sense of the carbon that's got into that? Well, this particular slide highlights that. So you've got these things called environmental product declarations or EPDs, and these are third-party verified certificates essentially for products, and there are thousands of them. I've heard somewhere there's 8,000, I've heard somewhere else there's 12,000, but there are thousands, if not tens of thousands, of materials which have been verified and are meaningful for us as Brits, putting this into software. So it factors in if it's coming from the States, what that means when it comes to the UK, Scandinavia, France, any country you can conceivably imagine. And this really helps us get some solid numbers for embodied carbon. And I'll show you later on, there are packages that you can use as part of the design process to very quickly give you that feedback. So essentially you can model a house, say we're going to be using these verified materials in it, and immediately it gives you a whole world of information, as little or as much as you want to help you figure out how far off the mark you are against these targets. And that's been a real eye-opener for us, and will bring a huge amount of value to your projects. So something that you thought was quite magical is actually now very, very tangible. Potable water usage, which is the third quadrant at the bottom left there, if you remember. Essentially, this is kind of drinking water. It's water. Part G of the building regulations looks after kind of water efficiency, and they're trying to drive this down by 40%. So at the moment, I think for 2020, the standard is 110 litres per person per day, and they're trying to drive that down to about 55 litres per person per day. So what does that mean? I mean, those are just numbers. What does that mean? And this is actually what it means. For most people, this is actually what it means. So at the moment, when 110 litres per person per day is often, we see this often asked for by building controls and planning departments already. So we're already at the kind of the 2020 target, and that's looking at low flow taps, dual flush toilets, you know, showers, you know, with flow restrictors on sometimes, and that's fine. You know, people usually, unless they want to be particularly extravagant, can hit that no problem at all. But as we move through the targets, it does become quite tricky, and there's some thinking to be done here about luxury and how we use buildings and bathrooms and those things in bathrooms and devices within buildings for future homes. Because for most people in most, let's pick a 4 or 5 bedroom house, for example, they will usually have 1 or 2 baths in there. And what we're actually finding is to meet the 2025 target, you can have a standard home, add on rainwater harvesting, and often it'll bring you down below 95 litres per person per day. To hit the 2030 target, just another 20 less litres often means that you'll have to exclude baths from the house. And as I say, you know, we've only done a few projects so far, but when you look at the calculator, it's very, very tricky to get down to that level. So showers are okay, but if you've got a 100 litre, 200 litre bath, that can be a really you know, really big issue, because there are certain usages which are assumed once you have those devices in there. You may put a bath in there and only have a bath once a month, but the calculator assumes that you have a bath, you know, every other day. So that can cause an issue. And so we have to think about that and get feedback when we're designing some of these things for more progressive homes to meet those end of decade targets. And then finally, kind of health and well-being. As I said, this is a kind of a new area, quite an exciting one, really, for in many respects, because what it aims to do is quantify how to live better and for the occupants to have greater levels of well-being, but also inform the design process. So rather than kind of dreaming up, you know, some nonsensical, you know, wordy targets, actually they've managed to condense health and well-being into some numbers, which is great. So the World Health Organization defines health and well-being as a kind of a state of complete physical, mental and social well-being, and not merely the absence of disease or infirmity, which is good to know. And well-being refers to a positive rather than a neutral state, framing health as a positive aspiration. That's great, and it would be nice to think that everybody you know, could enjoy spaces to that level. But as I say, these are words, but actually when we're as designers and design teams, we need a bit more than words, but that's the aspiration anyway. And we'll go on to exactly what that means. So primarily, I don't know if any of you guys were on the overheating webinar that I did, but increasingly occupant comfort is being eroded in buildings by increased levels of overheating. It can be any season, but typically in summer, as our buildings become more airtight, better insulated. The issue is not necessarily keeping people warm in the winter, it's making sure that people are cool during the summer. And where we use a lot more glass now, particularly on some buildings or flats where you might have a single aspect to let plenty of daylight in, it can be a real problem. And there is a standard, there's a European standard and a tweaked European standard for domestic buildings, which is TM59. And that's great. And I think more and more people are realizing that we need to assess buildings to a greater level of detail to make sure that thermal comfort it doesn't become overly risky, and you're aware of that before you finalize the design. But in this context, in the RIBA 2030 context, they've really upped the bar here, because what they're saying is by the end of the decade, the thermal comfort in a building is going to have to be 3 times kind of more comfortable is the wrong word, but the overheating potential is 3 times less, essentially 3 times less chance of being uncomfortable for a percentage of the year than is currently proposed. So at the moment, the European standard for the amount of, say, time if you spend in the building, you you're supposed to be uncomfortable is 3%. This health and well-being section talks about less than 1. And that might not seem such a big deal, but it is going to mean that you're going to have to in far more detail, shall I say, understand the building, understand how it's working, model it accurately, and potentially change the design to improve on that, and maybe make some tweaks and dare I say it, kind of compromises to achieve that, rather than just kind of taking in beautiful views and it's south facing and nobody wants any overhangs. That could be a thing of the past, and we all have a professional responsibility to meet client needs, design beautiful things, but also fully effective and functional things. And this is really kind of raising the bar to do that. So very much overheating analysis is a key part of health and well-being. CO2 levels, this is really just about better ventilation. All of the studies that have been done on CO2 levels are directly proportional to ventilation effectiveness. And again, we're used to buildings that have pull cords in the bathroom, ventilators in the bathroom, extractor hoods in the kitchen, maybe same thing in steam rooms or whatever. But as we move to mechanical ventilation and heat recovery and design ever more kind of complex buildings that need to be better ventilated, again, higher levels of design need to be put forward at earlier stages to make sure that the building is properly ventilated. Again, to reduce CO2 levels, to improve our kind of mental function and our feeling of comfort. So that's at the first stage, but also you've got kind of proper commissioning at the end, and post-occupancy evaluation and measurement also. Again, I've pulled up on other webinars about the fact that upfront design is fine, but you've actually got to push that through the rest of the design to make sure it's actually been achieved. And this performance gap thing is often talked about. But CO2 level is all about decent modelling of ventilation and proper practical ventilation within a building. VOCs and formaldehyde, these are quite tricky. This is less about modelling and just being more aware of the products and finishes that you're putting into a building, and as say kind of glues and adhesives that are being used potentially as part of the construction process, or finishes for a building. There's no point in going into kind of mega details about this, but those last 2 points are really just about more sensible procurement and just kind of keeping your eyes open about where you're sourcing certain materials from, to see that some effort's been put in reducing some of these quantums. So the final bit of the webinar here, I wanted to talk about kind of tools and assistance. So we've given you an idea of what the framework is about. I've given you an idea about the definitions of some of these things and what a building, what you might have to do as far as kind of design elements for a building, and some of the levels that you might have to meet with analysis. But actually, because we are doing some of this today and we are helping people design for this 2030 level, I wanted to share with you the kind of the methodology that we use, so that you can try and plug this into the way that you work and kind of see the sense in it. And I will guarantee that almost all of you, this will require a kind of a change in process. But hopefully, if I explain it properly, it should be fairly obvious what the benefits are. So, at the moment, as a business, we have this kind of green square at the top here. We've got a whole load of stuff that we do internally, and we help people out trying to figure out technology feasibility, the costs for technology, what's the right strategy. We've been doing that for years and years and years. We've also helped clients figure out, what the running costs might be for the home. So we've been inputting slightly into this kind of operation and energy part of the RIBA 2030 framework. For many, many years, at the bottom here, we've been doing stuff around the water efficiency levels, and this is this is often done for building regulations, and we've been ticking the box in the RIBA 2030 framework for potable water. So bits of RIBA 2030 we've been contributing to. But there's some key sections here, which is embodied carbon and health and well-being, and kind of beefing up the operation energy targets and data, which I strongly believe, and now Mesh Energy does as a standard, is the way forward to just how buildings should be designed from now on. And the missing piece here is in the middle. And fundamentally, what we're talking about here is building physics modeling, and this can start with building a 3D model and doing an overheating analysis of a building, and then having a bolt-on module. We use One-Click LCA and we use IES as a thermal modeling package. One-Click LCA helps us with costings and embodied carbon and whole life cycle carbon analysis. And these two things working together are a massively powerful tool. And the reason that they're powerful is because when you do the analysis, pre-planning or during detailed design phase, you get all of these outputs. So a TM54 analysis is a kind of a formal operational energy analysis for a building. We use these kind of verified EPDs and the RICS pricing database, which are built into all of these packages. That gives a big tick in the embodied carbon box, and also helps you get feedback about cost implications of reducing embodied carbon in a building. Ideally, you're trying to reduce carbon and cost. It gives you that feedback. The TM59 analysis, which is your essentially your kind of overheating analysis, that's done, so that ticks your big box in health and well-being. And CO2, so ventilation levels and daylighting, are also a key output. So by using building physics modeling, overheating modeling, and these key modules about embodied carbon, you can get all the data you need to make better informed decisions against this framework. And as I say, at the beginning of this year, we wanted to do this, and we hadn't done this. Now this is how we work. So for every project, really as standard, we build a thermal model, and we can get all of this information out against projects, and is the most robust way we can think of at the moment of making sure that you capture all these areas and really can be as successful with the design at an early stage as possible. You can see the benefits of this. If you did at least a light touch of this during pre-planning, it could catch out some stuff which affects your planning application. Beyond planning, you can really get into the detail and proceed with confidence into the specification design stage, knowing that you've put in the right amount of effort, and all you need to do now is get it executed. And as I say, this was a really simple graphic I put together against, you've essentially got the 4 RIBA 2030 blocks here, and the ticks are really just to say typically where you touch upon these during the project phases. So you've got pre-planning and concept design. So again, from kind of RIBA stage 2 onwards, really, you're starting to seriously think about this: detailed design, build, handover and use. And importantly as well, you've got the recognition phase at the end here. So, RIBA has declared that if you don't follow this framework and you're interested in awards, then you can kind of kiss that goodbye unless you can provide data which shows that you're putting effort towards, this RIBA 2030 framework. So if you've done all that as a kind of a natural part of the design process, it's there, it's ready for you to input. And I think based on feedback that I've got from other architects, it's about 60% of the the awards kind of points, should I say. So if you haven't got that, really, there's very little hope of winning one, sadly. But it does, it's a very good incentive to make this part of your design process. And there's all kinds of benefits. When you shake all this down, and this is something which you can appreciate as part of your internal benefits to you as a practice, but also share these with your client. We're all doing this for the benefit of the customer, so boiling the benefits down here through the stages should hopefully unlock your client to spending a bit more money at these different phases, particularly pre-planning, to really give them the best chance of a most robust and successful project later on. So as I said, when you're at the pre-planning stage, the benefits are you've made sure that the building's actually going to be thermally comfortable, and you haven't dropped a clanger on the south side of the elevation, or we're using a lot of glass, or you're trying to maximize views. Everything's okay, and you can proceed with comfort. If you need an overhang, you can design one in. If you need some other external furniture, you know about that before you go in for planning. And again, you know, with this other data, if you've done some of this initial analysis, you can have that to supplement your planning submission and give it a greater chance that, you know, the planners see that you've put some real effort into embracing, you know, sustainability for that particular project. And the chances are you'll have gone above and beyond what they even understand. So, you know, it should be a non-issue, and not something you see as painful. Obviously, detailed design, again, you're really getting to the detail. You're fine-tuning the details of the design. You can look at low carbon building materials and ideally reduce building costs. I firmly believe that you can actually drive the build cost of a project down by following this method and this methodology. So again, running costs and savings, the client's never going to argue with. And also it helps you with kind of clearer and easier kind of contractor price comparison as well. You know, through the build, handover in use, commissioning, and various other things, and recognition. These are all benefits when you think about them, which hopefully most of you would love to have on your project, and they are genuine benefits of you know, embracing this 2030 matrix and some slightly different methodologies and design process going forward. Well, just the final slide here was just kind of coming back to what we do as a practice. I say we cover off any stage of the RIBA kind of plan of works. The earlier we get involved, the better. I say we can get involved at a pre-planning stage, thermal design, feasibility studies, full M&E packages, the whole shooting match. Of course, we're happy to put kind of bespoke packages together for you guys. So I say we're always available and on the phone to try and help you out. And we appreciate that there's a lot of stuff changing here, and you know, we really are here to support as best as possible and make this transition in all manners of the word, you know, easier. You know, we are doing this. We've done it. This isn't you know, brand new for us. We are in the process of doing this with other practices as well, and we want to share all of those learnings with you. So, folks, questions. Have you guys got? I'm just going to pull up the chat thing here. Have you guys got any questions about that content that you fancy asking? I'm just looking at some of the questions that have come here actually. So Catrion has asked about the EPDs, and specifically, how would you calculate this against the carbon emission, i.e. the transportation of goods, products coming from other countries? So essentially, the EPDs, the way that they have, but as I say, because these are verified EPDs and they are for the UK, that calculation's already been done. I don't quite know how they handle if something's come over by, say, boat or aeroplane, or somebody swimming the channel, but those are all factored into the calculations, and they are kind of UK number specific. So if you pick something from France, there will be a factor in there that covers that mileage as compared to the US or China and various other things. So it's the best that they can do, but it is UK specific. Historically, there was a lot of USA specific EPDs and things like that, but the ones that are used in the packages, particularly one-click LCA, are all UK based. Has anybody got? I mean, feel free. We've obviously got the chat thing here. Feel free to unmute your mic if you just want to ask a straightforward kind of verbal question. How are we doing on time? We've got 15 minutes, so feel free to ask away. I won't bite. Here we go. So Katie's asked, is it possible that having full tight air building could be less sustainable than having a building that allows for permeability? Okay, so that's an interesting question. I guess anything's possible. I mean, what a lot of people don't appreciate is the fact that ventilation losses in a building are quite substantial. Once you've gone to the effort of improving the U values in the floors, roofs, walls, windows, ventilation losses in a building are at least, probably a third, or maybe even in the passive house, kind of half of the energy usage. And what I mean by that is, if you did have a leaky building, a building that wasn't airtight, and you were allowing cold air in, and this is particularly true in winter where your air temperatures are coolest. If you were letting that air in cold, it would add 50% to your heating bill if that was the case, to warm that air up. Because the other losses from the building are so low, ventilation is proportionally much higher. If you have an airtight building, yes, you have a small running cost associated with the mechanical ventilation heat recovery system, and yes, you've had to put a mechanical ventilation heat recovery system in, but you recover 90-95% in some cases of the warm air that would otherwise be leaving the building. So I think it's highly unlikely, and that's why people have gone that route. I mean, it's a whole nother discussion, and we've talked about this in webinars about using natural ventilation during the summer, and I strongly believe that hybrid ventilation strategies for buildings are the way to go. So you use a mechanical ventilation system during the winter, and then in the summer you let the air in, you let kind of nature ventilate the building, and that's really effective for stopping overheating as well. Helen's asked, as with the Code for Sustainable Homes, are these requirements likely to be made a condition for planning consent or remain under building regs? Another good question. So the RIBA 2030 framework at the moment is very much voluntary. So in that sense, it's kind of similar to the Code for Sustainable Homes. I think building regulations will tighten. So building regs will kind of catch up with the way that this document is traveling. Whether the planning guys will actually force RIBA 2030, I'm not sure. If you guys are familiar, there is a replacement for the Code for Sustainable Homes, and that's the home quality mark. So this is kind of like the domestic lighter touch equivalent to BREEAM, really. And many would argue that the home quality mark is just a retitled Code for Sustainable Homes. Now, the planning guys haven't included that, although they did Code for Sustainable Homes. But they may do. Who knows what the planners are doing? I mean, planners every day are announcing more and more climate emergencies as far as the kind of the councils are concerned. And something will happen. What it's going to be, I don't know. And I guess ultimately you could still have a client which was saying, well, if we don't have to do this, why are we? But you professionally think that it should be done. And it's worth asking yourself, do you want to be working with those kinds of clients? And then that's a pretty serious question. I think a lot of practices are going through that thinking, how do we, if we think we have a professional responsibility and we think it can be achieved without adding excess cost to building, that's something that we would like to be doing. And so the next step is finding and helping clients become engaged with this. Because it's really powerful. Once you have a client that's engaged, you guys know it's the right thing to do. Only good things can happen if you've got the right design team. So hopefully you can do a lot of this without relying on planners asking for it. But the likelihood is building regs will tighten, and planning departments, once they've settled down a bit, will seriously consider over the next kind of 24 months, including some of these things. But who knows? It may do, it may not do. I'd like to think the industry could push ahead of kind of building controls and things like that. But we shall see. Okay, if anybody else has got a last question, I'll give you a short stint of time to ask that. As I say, feel free to ask one verbally if you want to. Otherwise, we'll wrap it up. So just give somebody a few more seconds if they just want to punch in a last minute question. If not, I don't think anybody else has got any other questions. thanks guys for your time, and great to have you on here. What I would just say, I said that I would mention about some of the other webinars coming up. This has been a great series for us, and we're going to push this on until people get bored of listening to me. So we've got a number of topics coming up. So next week is called Watch Out Biggest Eco Project Pitfalls. So this is about mistakes which we see consistently being made on low energy projects. And we'd invite you to have a look at that, and hopefully we can help you avoid those. Smart low energy building design, which is a rerun of the one that we did last week, which is about the book that I wrote about kind of fundamentals of low energy building design and practical tips through the stages. And then the final one in May is about why build an eco home. So the kind of the benefits explained for yourselves as practice, but also for your clients. I know that's a tricky area for architects sometimes to get across. What are the actual benefits of building a low energy building beyond kind of reduced running costs? And then in June we've got all kinds of other topics, but we'll be posting them on LinkedIn. I think Rhiannon put something on there about feel free to ask us any questions on the info@mesh-energy email address. And we look forward to seeing you guys next time around. Thanks for your time, guys. Hopefully you found it insightful. I'm just seeing some other stuff going up on the chat here.
Just to answer, Stina, there will be a follow-up email coming out with the slides attached in all of our upcoming webinars, for sure.
All right. Cheers, guys. Until next week, have a good one. Take care. Bye.